Hello everyone. Today we will going to see some practice questions from the topic electrochemistry, and this is part 5. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is index slide and we will going to see the practice questions, and it is from 32 question number to the 38 question number. So let's start with the question number 32. Given E naught of Fe3 positive Fe is minus 0.036 volt, E naught for Fe2 positive Fe is equals to minus 0.439 volt. The value of standard electrode potential for the change Fe3 positive plus electron giving us Fe2 positive will be. So we have to find out the standard electron potential for this reaction. We have given the E naught for Fe3 positive and Fe and the E naught for Fe2 positive to Fe. Options are minus 0.072 volt, 0.385 volt, 0.770 volt, or minus 0.270 volt. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is 0.770 volt. So, as the E naught is given for the Fe3 positive to Fe, so the reaction will be for the E naught Fe3 positive plus 3 electron giving us Fe atom. E naught 1 for this reaction is given as minus 0.036 volt. Similarly, we have given the E naught for Fe2 positive to Fe, that is Fe2 positive plus 2 electron giving us Fe. So E naught of 2 is equals to minus 0.439 volt. Okay, so this is the second reaction for the second given E naught standard electron potential value. Now we have to find out the standard electrode potential for this third reaction. Let's suppose this is third. Fe3 positive plus electron giving us Fe2 positive. What will be the E naught 3 for this reaction? So we can obtain third equation by subtracting second from first. Okay, so what we are saying that we can get this final reaction for which we have to find out the standard electrode potential. We can obtain this third equation by subtracting this second equation from the first equation. So if we subtract these two, we can get the third equation. But we cannot obtain the E naught 3 that way because electrode potential is intensive property. And because it is an intensive property, we can't get it by either adding or either subtracting or multiplying by anything. That's why we determine the E naught 3 calculating. What we will do, we will just write the equation in the form of the del G. So del G naught for 3, yeah, that is third equation, is equals to del G naught for first minus del G naught for second. Why we are doing this? Because E naught is an intensive but property, but del G naught is an extensive property. Okay, so that's why we can use the del G naught equation here. So del G naught, del G is equals to minus NF E naught, right? E naught and del G is related by the equation that del G is equals to minus NF E naught. Now we just write the value for the first and second equation of del G. It will be minus N is 3 for the first equation. Let's see here. So for the first equation, N is 3. So minus of N is 3 times F and E naught. E naught is this one. So minus will become plus. So it will be 3 times 0.036 times F. Similarly for del G2, minus N F E. So F we take common, N is 2 for the second reaction, and E naught value is 0.439 for the second reaction. And minus minus will become plus, minus NFE, and the E naught value is also in negative, so minus minus will become plus. So only this minus which we are subtracting, which we are using in this equation, is coming here. So del G naught 3 will be equal to 3 times 0.036 minus 2 times 0.439, and we take F as common. Now del G naught 3 is equals to minus NF E naught 3, right? This is the equation for del G naught. This is the relation between the del G naught and E naught. So we just write it for the third equation and we just solved it. It will be 0.108 minus 0.878 F is Faraday. So you can see F is a constant. So one Faraday will be 96500 coulomb. So here also F is F is coming, and here also in the right hand side F is coming. We just cancel out this, and other than that we just put the value whatever we have given. So N for the third reaction is 1. So minus 1 times E naught of 3. And E naught of 3 is what we have to find out. So this is the variable here. And on subtracting this, it is equals to minus 0.770. So E naught 3 will be equal to positive 0.770 because minus will cancel out. And the final value of E naught will be positive 0.770 volt. Okay. And thus our option C is the correct answer. Okay, now let's move to the next question. Question number 33. Galvanization is applying a coating of. So first of all, we have to know the process of galvanization. What happened in the process of galvanization? And we have asked that in this process, applying a coating of what is known as galvanization. So options are chromium, copper, zinc, or lead. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see the correct answer, which is C option, that is zinc. So basically, according to the galvanization concept, zinc metal is most stable metal to cover the iron surfaces, and the process of coating the iron surface by the zinc is called galvanization. So galvanization is a process of coating of iron surface by the zinc. Okay, zinc coating will be used to prevent the iron surface from rusting. Okay, so the galvanization is the name of the process, and the zinc metal is used in this process. So C option is the correct answer. Okay, let's move to the question number 34. Match the following and choose the correct option. So we have given a table here in which two columns are present, column first and column second. So there are 4 rows. We have to match the rows from column first to column second. Lead storage battery, mercury cell, fuel cell, rusting. In the column second, we have maximum efficiency prevented by galvanization, gives steady potential, lead is anode, lead oxide is cathode. Okay. Options are A to 4, B to 3, C to 1, D to 2, A to 2, B to 1, C to 3, D to 4, A to 1, B to 4, C to 3, D to 2, A to 4, B to 1, C to 3, D to 2. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay. So let's see the answer. The correct answer is option A. That is, A is for fourth, B is for third, C is for first, and D is for 2. So A, the A is lead storage battery. So lead storage battery In the lead storage battery, lead is anode, acting as anode, and lead oxide is cathode. Okay, so A is relating to fourth point in the column 2. And for the mercury cell as B option, as B point in the column 1. So as mercury cell is primary battery, it gives steady potential. So B point in the column first is related to the third point, that is in the column 2, that is gives steady potential. Now third point, that is C point in the column 1, fuel cell has maximum efficiency, which is given as eta is equals to del G by del H times 100. Okay, this is the efficiency formula for the fuel cell. Fuel cell is having maximum efficiency. So C point in the column 1 is related to the first point in the column 2, that is maximum efficiency. Now D point for the column 1 is rusting. So rusting of iron can be prevented by the process of galvanization. Okay, so the D point in the column 1 is related to the second point prevented by galvanization in the column 2. Okay, those are A option, that is A to 4, B to 3, C to 1 and A to 2 is the correct answer. Okay, let's see the next question. Question number 35. This is the direction given. So in the following questions, assertion followed by region is given. Choose the correct answer out of the following choices. So assertion is given as E of cell should have a positive value for the cell to function. Region, E of cathode is less than E of anode. Options are assertion and region both are correct statements, and reason is the correct explanation of assertion. Assertion and reason both are correct statements, but reason is not the correct explanation of assertion. Assertion is correct and reason is correct. Both assertion and reason are incorrect. So you have to choose one as per the given assertion and reason statements. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay. So let's see, the correct answer is option C, that is assertion is correct, reason is incorrect. So as you know that for the spontaneous reaction, del G should be negative and E of cell, therefore E of cell should be positive. For del G should be negative, E of cell have to be positive, right? So assertion is correct. E of cell should have a positive value for the cell to function. This is correct. Now reason is wrong. Why? Because the correct reason is that E of cell is given as E of cathode minus E of anode. Okay. Now E cell is positive, as we have given in the assertion that E cell is positive when the E of cathode is greater than E of anode. If E of anode will dominate, then this whole equation will become negative and E cell will be negative. But as E cell is positive, so E cathode should have to be positive. Should have to be greater than E of anode. That's why reason is the incorrect statement and the C option is the correct answer. Okay, let's move to the question number 36. Similarly, here also assertion and reason are given and we have to choose the correct answer out of the following choices we have given in the options. Assertion is E of Ag positive to Ag increases with the increase in concentration of Ag positive ions. Reason, E of Ag positive to Ag has a positive value. Options are assertion and reason both are correct statements and reason is the correct explanation of assertion. Assertion and reason both are correct statements, but reason is not the correct explanation of assertion. Assertion is correct, reason is incorrect. Both assertion and reason are incorrect. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay. So let's see, the correct answer is option B, that is assertion and reason both are correct statements, but reason is not the correct explanation of the assertion. So reason is not the correct explanation, while the A and R, assertion and reason both are correct. So assertion is E of Ag positive to Ag increases with the increase of concentration of Ag positive. So this is correct, and the reason is E of Ag positive to Ag has a positive value. This is also correct. Both are correct. Okay, but it is not the correct explanation. So basically correct explanation is that Ag positive plus electron giving us Ag atom, and the E of Ag positive to Ag is equals to E naught of Ag positive to Ag minus RT by NF log 1 upon Ag positive. Okay, so this is the correct explanation, and the correct reason is not the correct explanation, and thus our B option, that is assertion and reason both are correct statements, but reason is not the correct explanation of the assertion, is the correct answer. Okay, let's see the question number 37. Direction. Each of these questions contain two statements. Statement 1 assertion and statement 2 reason. Each of these questions also has 4 alternative choices, only one of which is the correct answer. You have to select the one of codes from A, B, C and D given below. So statement 1 is, for the Daniell cell, zinc 2 positive, salt bridge, copper 2 positive copper with E cell is equals to 1.1 volt. The application of opposite potential greater than 1.1 volt results into the flow of electron from cathode to anode. Statement 2, zinc is deposited at anode and copper is deposited at cathode. So options are statement 1 is true, statement 2 is true, statement second is a correct explanation for statement 1. Statement 1 is true, statement 2 is true, statement 2 is not the correct explanation for statement 1. Statement 1 is true, statement 2 is false, or statement 1 is false, statement 2 is true. You have 10 seconds to solve this question. After that, we will see the answer. Okay. So let's see, the correct answer is option A, that is statement 1 is true, statement 2 is true, and statement 2 is the correct explanation for statement 1. So in the Daniell cell, zinc 2 positive, salt bridge, copper 2 positive, copper, E of cell is 1.1 volt. That is given. The reaction of oxidation half cell is equal to this, that is zinc giving us zinc 2 positive plus 2 electrons. So the oxidation half cell is this one, and the reduction half cell is this one, copper 2 positive plus 2 electron giving us copper. So overall reaction will be zinc plus copper 2 positive giving us zinc 2 positive plus copper. Now because zinc is oxidized, it is deposited at anode, and copper is reduced, so it is deposited at cathode. If the opposite potential is greater than 1.1 volt, then the electrons flow from cathode to anode, and both the statements are true and correct explanation. Okay, so basically we just write the half cell oxidation and reduction reactions, then the overall reaction, and as it is given that zinc is oxidized, then it means that it is deposited at anode, and copper is reduced, that means that it is deposited at cathode, and the opposite potential greater than 1.1 volt, then the electrons flow from the cathode to anode, and thus are both the statement first and second is true, right? Because it is given that the application of opposite potential results into the flow of electron from cathode to anode. So it is correct. And the zinc is deposited at anode and copper is deposited at cathode. This is also correct. Okay. So A option is the correct answer. Okay. Now let's move to the next question. Question number 38. Similarly, here also we have statement 1 and 2, and we have to select the correct option by looking at the statement first and second. Statement first is galvanized iron does not rust. Statement 2, zinc has more negative electrode potential than the iron. Options are statement 1 is true, statement 2 is true, statement 2 is a correct explanation for statement 1. Statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. Statement 1 is true, statement 2 is false, or statement 1 is false, statement 2 is true. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see. The correct answer is option A, that statement 1 is true, statement 2 is also true, and statement 2 is a correct explanation for the statement 1. So galvanized iron, that is iron coated with the zinc, does not rust, because we do the galvanization process for the iron for the prevention of rusting, right? Easily, as zinc has more negative electrode potential than the iron. So zinc has more negative electrode potential, so its reducing power will be uh, less. Okay, because the negative electrode potential, zinc has more negative electrode potential, that is 0.76. So it can't be oxidized to the rust. Okay, and that's why galvanization or galvanized iron does not rust. And why? Because zinc has more negative electrode potential than the iron. So option A, that is statement 1 is true, statement 2 is true, and statement 2 is the correct explanation for the statement 1, is the correct answer for this question. Okay, thank you.